Hi guys, this is me again. My name is Joseph Ejike Oji. We are still on the concept of probability. In my previous lectures, I showed you the basic concepts and we did sample space, outcomes, etc. In this lecture, I'm going to introduce you to the different approaches to probability theory, or what I call the types of probability. I hope you enjoyed this lecture because I'm going to make it as simple and as enjoyable as possible for you. Okay? Now, let's proceed. The types of probability. There are three basic approaches to probability, and they are here. You can see right here. We have the classical probability, the empirical or relative frequency probability, and the subjective probability. In this lecture, we focus more. In fact, this lecture will be about classical probability. In other lectures, we discuss the other remaining types of probability. Okay? The classical probability. The classical probability is based on already known sample spaces. That is, the sample spaces that we already know. For example, we know that a dice have 6 sides. So the sample space for a dice is 6. A card has a deck of cards is 52 because it has 52 cards. So the sample space is 52. The days of the week, for example, we have 7 days of the week. So the sample space is 7. So this is basically what classical probability is about. It's about the sample spaces that we already know. So for this method, we use this formula for calculating the probability of an event. Let us say that the event is E. Then the probability of this event E is number of outcomes in E divided by the sample space. Okay? Now, let us try some examples. Look at this example. It says, you roll a die 6-sided. You roll a 6-sided die. Find the probability of each event. Event A is rolling a 3. Event B is rolling a 7. Event C is rolling a number that is less than 5. Before we can answer this question, we need to look at the sample space for a dice. Okay? This is the sample space for a dice. Okay? 1, 2, 3, 4, 5, 6. It's 6. With this, we are ready to calculate the probability. The first one says the probability, the event A, which is rolling a 3. So there's, in this sample space, you will see that there's only 1 3 here. See? So the probability of this event getting a 3 is only 1 out of 6 chances because there's only 1 3. Okay? Now the second event, the second question is rolling a 7. Now let us look at the sample space. You see here that there is no 7 in the dice. So that means there is 0, 7, which means that the probability of event B getting a 7 is 0 out of 6 chances. Okay? Event C, as the third question says, rolling a number less than 5. So look at the sample space again. How many numbers are less than 5 here? They are 1, 2, 3, 4. 4 of them. So the probability of this event getting a number that is less than 5 is 4 out of 6 chances. We got give us 0.667, which can also be called 66.7%. Why? Because we can write probability answer as a fraction, a decimal, or a percent. The same thing applies here. The first one, where we have our answer as 1 or 6, which is 0.167 or 16.7%. Okay? Now, let us answer a more challenging question. Remember, it is still classical probability. It says here, a roulette wheel has 38 slots, numbered 0, 0, 0, 1, 2, 3, all the way to 36. Half 1 through 36 are red, and the other half are colored black. The remaining number 0 and 0, 0 are colored green. Find the probability that a ball lands on A black number, B, a green number, C, a 10. Okay? Before we can answer this question, we need to see how a roulette wheel looks like. Look at a roulette wheel right here. When you get closer, you can see the green slots right here and the red slots and black slots. Okay? In total is, and if you count them, you see that they are equal to the number mentioned in the question. Now we can go back to our question. The first thing we do is to find our sample space, which are here. The question said that we have half 1 through half of it has 38 slots, 0. Okay, half of 1 through 36. That means 18 of them, because if you count them from here, black, if you count the black edges here, you see that they are 18 in number. And if you count the red ones, they are also 18 in number. The green ones are only 2 of them in number. So we have them in the table in this form. Okay? Red 18, 18 of red, black 18, green 3. That gives us the sample space of 38 slots. Okay? Now, let us answer the question. The probability that it's fall on the black number, we have how many blacks here? 18. So out of 38 slots. So the chance is 18 out of 38 slots, which means that the probability that the ball fall on a black number is 18 out of 38, which is 0.474 or 47.4% chance. Part B is asking the probability that the ball falls on a green number. How many green numbers we have here? Only 2 of them, 1 and 2. And from the table, you can see right here, only 2 of them. So the probability that it falls on the green number is 2 out of 38 chances, which is 0.053 or 5.3% chance. Okay? The last question is asking the probability that the ball falls on a slot that is numbered 10. Now we ask ourselves, how many slots are numbered 10 in that roulette? Look at it right here. only one of them here is number, only one number is 10. Only one slot had numbers 10. See? So that the probability that it falls on the 10 is 1 out of 38 chances, which is, when you put this on the calculator, 0.026 or 2.6%. This answer now concludes our lecture on classical probabilities. In the next lecture, we will be discussing empirical probability. Okay? Thank you for listening, and I hope you enjoyed it. Bye-bye.